Cool. So today we are going to be talking about creational design patterns. So we already talked about factory method, abstract factory in the previous class. Today we are going to be discussing 3 more creational design patterns, and we'll be finishing creational design patterns. So let's take them one by one and understand the different problems that we are trying to solve and how, like, what are the different possible ways of solving them. So once we are done with creational design patterns, what I want you to do is start comparing these, like maybe after today, like tomorrow in the starting of the class, we'll compare and we'll understand properly that how objects are created and exactly, what will be the thought process behind creating different kinds of objects, right? Pratik is asking, factory is also creational. Pratik, this is like asking who was Ram Bhagwan after we have finished the entire Ramayana. But okay, factory, we are creating objects, right? Factory creates creational design pattern. But okay, cool. It's fine. It happens with all of us. So starting with a problem that I want you to think and how we can solve it. Is factory a good enough way to solve it, or is there any better way of solving it? Okay, so today I want you to make some desktops. Okay, now desktops can be of the type, say, Dell desktop. It can be an HP desktop, or say a Sony desktop. And as you might have guessed by now, that we should be able to add more desktops, seamlessly. We should be able to remove desktops seamlessly, right? So now when we talk about creating these desktops, you might think that we already know this, Keerti, factory design pattern, just create a separate factory class and it is going to take care of the creation. That's what you all can think of? Yes? Yep, factory for the creational part. But now, yes, can I get more quick yeses? I want to make sure that all of you are listening to me. Yes, all of you think that we should be using factory. But now let's understand how this case is different from whatever cases we have dealt so far. Now let's see what are the different things that we would have to do while building a desktop. Okay, we would be setting up, say, RAM. We would be setting up, say, processor, a monitor, a keyboard, right? And what else do we set up? What else can we set up in a desktop? Tell me. Monitor, keyboard, processor, RAM, mouse. Okay. What else? Speaker, printer, right? So now the thing is that we have to set all of these things in all of these objects, right? The thing is that creation process is same. If you think about it, how this case is very unique is that the construction process is same for all of these objects, right? So it is same for Dell desktop, for HP desktop, and for Sony desktop. How is it same? That they would all have to create the RAM, processor, monitor, keyboard, mouse, speaker, printer, all of it. But what we would have to do is we would have to do a lot of configurations. That we would have to mention that this type of RAM for Dell desktop, this type of RAM for HP desktop, this type of RAM for Sony desktop, this type of monitor for Dell desktop, this type of monitor for this type of monitor for this. So do you understand the case over here that I'm talking about? That the steps to be followed is same. It is a complex process. The creation is a complex process, right? If I have to create a desktop, it is complex because I have to follow all of these steps, right? But the steps are common, right? I just have to do a lot of configurations. Does it make sense? Yes or no? Can I get yeses? By the way, is there any sound disturbance or are you able to hear me properly? Give me 1 second. I left the fan on. I'll just switch it off. Give me 1 sec. Okay, now it should be better. So now you understood the case that desktop, we have to create types of desktop. It can be Dell, HP, Sony. It will have different steps. It will have, like, we will have to create RAM, processor, monitor, keyboard, mouse, speaker, printer, so many things. But the configuration for all of these objects, for Dell desktop, for HP desktop, for Sony desktop, is going to be different. The construction process is same, the configuration is different, the creation is complex. This much understood, everyone? Yes? Yep. Okay. Now my question to you is, isn't it obvious that, we all know that we want to follow solid principles and make this as extensible, maintainable as possible, correct? So we all know that we want to do that. Now the point is that what if I create another class, say a builder, and make this an abstract class or an interface? Okay, and let me explain to you that why am I saying that we should be doing this? Basically, what do we do in abstract class or interface? We discussed last week, right? We set some contract. We tell that this is the template, and whatever methods are there in this builder, all the classes that inherit or that implement or extend this builder will have to have those methods, correct? So now, what if I create functions inside this like build RAM or build processor, right? Build monitor, build keyboard, and so on, right? So basically, in terms of C++, you can look at them as pure virtual functions. In terms of Java, you can look at them as abstract methods. Basically, these are the methods that all the classes who know. Anyone knows how to mute the chat? Okay, let me see if I can do that for you. Give me 1 second. I guess it is disturbing some people, right? Give me 1 sec. Let me see if it is possible. Turn off chat previews. Yes. Okay, cool. So you guys can also do that. Okay. So have you understood this much, that why am I saying that you should have a builder class, right? So now what is going to happen is that I have a class builder. Whichever classes implement this builder or extend from this builder will have to implement these abstract methods. We'll have to have build RAM, we'll have to have build processor, we'll have to have build monitor, keyboard, speaker, printer, so on. Correct? So now what is going to happen is that when we implement or extend, basically I'm going to have different builders. I'm going to have Dell desktop builder. I'm going to have HP desktop builder. And I'm going to have, say, Sony desktop builder. And so on. So all of these, Dell, HP, Sony, they will have to have this build RAM, build processor, build monitor, build keyboard. And what will happen? They will just mention that, okay, Dell desktop builder, I will have this RAM, or I will have this processor, or this monitor, or this keyboard. Correct? I know it can be a bit confusing. Let's start from the starting and let's try to understand how this is different from what we have done so far, right? So what I will repeat everything from the starting so that it becomes more clearer. So I said that we have a desktop product. Okay, so what am I calling this? I am calling this our product. Then I said there are types of products that I want to have. One is Dell desktop. One is HP desktop. One is Sony desktop. Okay. Now you said that we can have a factory and we can just make the creation process different. So in factory, what we would have done, we would have like a class factory and we would have done like this, that if it is like Dell type, create Dell desktop or create HP desktop, correct? Or create Sony desktop. But within this, we are doing the same thing, right? We are actually building RAM, processor, monitor, keyboard, mouse, speaker, printer. What we are doing from creating an extra builder is that we are setting a template. Because I made it an abstract class or an interface, all of the classes that implement or extend this builder will have to have all of these methods, right? If we would have used a normal factory, what would have happened is that how we are creating Dell is completely different from how we are creating HP, might be completely different from how we are creating Sony. There is no particular template that we have to follow. It is not necessary that I am adding all RAM, processor, speaker, printer. I might miss adding printer, right? Or I might miss adding speakers. But I want to make sure that because I am building a desktop, I want all of these things to be there. Make sense? Does it make sense so far? Yes. So now what did I say? That because we have to build construction, the construction process is same. The steps to be followed while building is same. What I have done is I have created a builder, right? And in this builder, there are abstract methods like build RAM, build processor, build speakers, and so on, right? So all of these abstract methods need to be implemented or extended by each of the builders. So we will have what kind of builders? We will have Dell desktop builder. We will have HP desktop builder. And we will have Sony desktop builder. Correct? Now, these are what? These are concrete builders. I saw someone asking in the Discord that what is concrete builders? Basically, there's an interface on an abstract class when we are implementing those. Okay, so basically this interface is doing what? It is setting a template for us that you have to have build RAM, you have to have build processor, you have to have build speaker and all of that. And we are implementing those methods, right? So these are the concrete classes. And this is an interface. Builder is an interface, and Dell desktop builder, HP desktop builder, Sony desktop builder. Let me call this desktop builder. This is just a desktop builder. It is not specific to Dell or HP or Sony. It is setting a template for us. Correct? So Naveen is asking, are we saying that the builder is for complicated process? Yes. So the complex will be the creation will be complex, but there are a lot of steps involved, and the steps are same for different objects. And there are a lot of configurations also to be done. Imagine like this, okay, if we did not know anything about builder, how we would have done? We would have a Dell desktop builder, and we would have probably created constructors that, okay, this is the RAM, and this is the processor, this is the speaker, this is the printer, this is the motherboard, or whatever, like mouse, keyboard. These are the different configurations that we have. Now, for every single desktop that comes, we would have to create a different builder, different basically constructor. If you think about it, if we were not following builder, just forget about this. If we were just following normal, like we don't know what is builder, okay, we do not know, and we are trying to implement this, we would create a constructor like this, right? Dell desktop, and we would pass RAM, processor, speaker, printer, this and this. Now, every time a new type of desktop comes, like Dell desktop was there. Now, if I have HP desktop, I would have to have another constructor with so many parameters, yet another constructor with so many parameters. And suppose I have to set something, like suppose I have to set a speaker in something, or I have to set a mouse in something. Instead of using the same constructor, I might have to pass the values again. I would have to change the values again and pass them. You understand the problem over here? Firstly, there are too many parameters to be passed in the constructor. It is not good. Secondly, the process is same. We want to regulate the process. We want to set a template for the process that you have to do this, and then this, and then this, and then this, and this is how the building is going to complete. Make sense till now? Yes? Configuration is there, correct? Now you have understood that there's a lot of configuration. There are some processes, and we have some builder classes who have implemented these processes that, okay, they are building RAM, building process, building speaker. Now my question to you is that when are we going to call this build RAM or build processor or build speaker or build keyboard? And who is going to call them? Who is going to call these methods? Okay, let me repeat my question to you. So this desktop is our product. This is our interface, right? These are what? These are our concrete builders. Concrete builders. Who is going to call these methods? Build RAM, build monitor, build keyboard, and so on. Who is going to call them? Okay, so for that, we are going to have a different class and we are going to call it a director. Okay, I know guys, for now, it might feel that, it is too overwhelming. Why are we doing so much for just creation? But in reality, when there are, say, dozens of parameters and so many methods and, so many things need to be set up during creation, it does make sense. Okay, when we take examples like just desktop or home and, we take simple examples to understand the concept. But in reality, what is going to happen is that there are going to be so many parameters, so many configurations. And in these cases, using a builder design pattern is going to really work. And I'm going to give you really good 2 examples, real life implementations where these are used. Okay, so stay patient and try to understand. One of the major disadvantages of builder design pattern is definitely that there's a lot of code. Okay, the number of lines of code is a lot. And that is why builder is probably one of the most confusing design patterns also. So if you understand this, you all can be very proud that you have understood one of the most hard design patterns ever. Okay, so have full attention over here. Even if it feels overwhelming, just try to understand why we are doing everything. Why do we need a product? We are creating a product. Why do we need a builder? Because there is a same process. We want to have a template for the process that build this, then build this, then build this, build this, build this. Okay. Now there are concrete builders who are actually doing the building. So like Dell desktop builder is actually building the RAM, the Dell RAM, the Dell processor, the Dell monitor, the Dell keyboard. HP desktop builder is actually going to build the HP RAM, the HP processor, the HP monitor, the HP keyboard. Correct? What is director doing? What director is doing is actually calling these methods. And how will we do that? The director is going to have the builder, the concrete builder. It will have the object that exactly what are we building? Are we building Dell desktop? Then it will have Dell desktop builder. If we are building HP desktop, then it will have HP desktop builder. If we are building Sony desktop, it will have Sony desktop builder. And then what it is going to do, it is going to say builder dot build RAM, builder dot build processor, builder dot build keyboard, builder dot this, builder dot this. Basically, it is going to call all the abstract methods. Do you have some idea now? Like what am I talking about? Some rough idea? Rough idea do you have? Let's try to look at the UML. How does the UML look? And we'll take more examples first of all, and we'll also look at the code so it will be clearer. Okay. So let's draw what all different components are there. Okay. We understood that there is a director, correct? So director is the name of the class. I said that builder is going to be there inside this as a member. So I'm adding builder. And suppose there is going to be a construct or a build function. And what are we going to build in this? We are going to build the desktop, correct? So here where I call construct, I'm actually inside the constructor, I will be doing builder.build RAM, builder.build processor, builder.build keyboard, builder.build mouse. Okay, again, what is director doing? Director is just saying, okay, please guys, okay, cool. Okay. No, never mind. So in director, what are we doing? We are constructing the method one by one, right? So in construct, we are calling build RAM, build processor, build this, build that, build this, correct? So we are actually calling the functions then. So director is a different class, which is actually going to direct that how the build process is going to happen, right? This builder in director is concrete builder. No, wait. So this builder, okay, are you saying this builder in director is concrete builder? Yes, correct. So this is a concrete builder. So you will see in the code that when we pass builder inside this, we will actually pass that is it a Dell desktop builder or is it a HP desktop builder or is it a Sony desktop builder? So builder is another class and there is just like I'm just adding one constructor, nothing else. Okay. For now, I'm just adding this. Now, in this builder, okay, first of all, we talked about that director has builder, right? So has a relationship. What was the relationship? What was the relationship? Has a relationship. Do you guys remember? What is it called? What is it called? Has a relationship? Aggregation. Correct. Guys, can you give me just 1 second? I will be back. Give me 1 sec. Okay. My phone was getting discharged. Sorry, I wouldn't be able to see the chat. Okay. So our director is a class that is responsible for calling the construction process that you need to construct it now. Okay. Builder is basically going to set that, okay, these are the functions that you will have to implement. From this, we are going to have what? We are going to have concrete builders. So they are going to be, these are concrete builders, right? And these concrete builders, what are they doing? They are actually going to create the product for us. Correct? Yes, does it make sense? Okay, can we look at the code and then we will take more examples to understand? Yes, can we quickly look at the code? I guess it will be clearer. Okay, give me 1 second. I will take more examples and look at the code again, so it will be clearer. Don't worry. Can you all see the code properly? Yes? Okay. So this is basically, okay, so this is my product. You remember product that we had desktop. Now desktop, for now, I have added everything as string itself. So there's a motherboard, there's a processor, memory, storage, graphics card, all of that is there. Okay. So there's desktop. This is the product. Desktop builder, as you can see in C++, these are all pure virtual functions. Pure virtual functions means what? Desktop builder is an interface or an abstract class, right? For now, okay, notice small details over here. For now, I have done what? I have a build over here, right? So if I have a build function, that means because I have implemented something over here, for now it is an abstract class and not an interface, because I have something over here that is happening, correct? So it's not all functions are basically pure virtual functions. That is why this is an abstract class, correct? Now, another thing that you should be thinking, when you look at the code, I want you all to start thinking of these things. The product over here is desktop and it is protected. Why is it in protected? Because I want my concrete builders, my Dell desktop builder, my HP desktop builder, my Sony desktop builder to be able to access this desktop product. Correct? I know that a lot of us are very used to having, only private and public members. So you should know when to use protected also, right? So it does make sense to you, right? That why are we using protected over here? Yep. I'm looking at the chart. Okay. Yes, I will show the Java code also. Don't worry. It will become clearer. Don't worry. So this is the product. This is the desktop builder. It is the abstract class. Now, what are the classes that are implementing this desktop builder? This desktop builder is being implemented by what? Dell desktop builder and HP desktop builder. What is happening in Dell desktop builder? We are just setting Dell motherboard, Dell processor, this, okay, this is the storage, this is that. Okay, there are two versions of the same code. For now, this is the one that I want you to focus on. Okay, so in desktop, I've just added one display. In desktop builder, these are pure virtual functions. In Dell desktop builder, I have just done build motherboard, build processor, build memory, build storage, build graphics card. Okay, HP desktop, again, HP motherboard and its own configuration. Okay, so there is Dell desktop builder and there is HP desktop builder. Now, there is a director. What is director doing? Now, notice over here that I am passing the builder in desktop builder, in desktop director. Okay, understand this properly. Okay, and now full focus over here. It will get clearer now. Notice this. I created a director. That was the first thing that I did. director. Okay, nothing is there. I just created one director, Dell Desktop Builder. And when I tell this director that you're supposed to build desktop, I am just passing the Dell Desktop Builder. Over here, I am passing the HP Desktop Builder. Nowhere else am I talking about that whether it is Dell or HP or Sony or whatever it is. The only place where I'm telling that it is Dell or is it HP or whatever it is when I am creating the builder. Correct? So I am passing what? I am passing the concrete builder to the director. It will get clearer. I'm going to repeat all of this. Okay, yeah, I'm going to repeat all of this. Don't worry. What in the director, I am passing the concrete builder. And in this build desktop, I am calling all of the functions one by one. Let's look at the Java code also once. Okay. I will explain it again, guys. Don't worry. See, desktop is the product, right? There is just one display function over here, and all of whatever parts are there in desktop, right? So there is motherboard, there is processor, memory, storage, graphics card, all of that is there. And then there are getters and setters. Simple, right? Product. It's getters, setters, nothing else. Then there is a builder. In builder, what is there? There are a lot of abstract functions, abstract methods. What are we doing in these abstract methods? We are just building motherboard or building processor or building memory, building storage, building graphics card. Abstract methods means what? That all the classes that inherit from over here or implement desktop builder will have to have these methods, will have to implement these methods, correct? Dell desktop builder is one such and HP desktop builder is the other one. In Dell desktop builder, what am I doing? I'm just setting that, okay, Dell, these are my configurations. In HP, I'm just saying, okay, HP motherboard or whatever are my configurations. I am just putting the configurations. So if we were not using builder design pattern, I would have passed all of these configurations in constructors. I would have had huge constructors. And it is always better that I have proper methods, small methods, and it is more readable like this, right? You can read all the configurations that, okay, this is the process, this is memory, this is this, this is this. Usually when you look at constructors, your code is not readable, it is not maintainable, it is not extendable. If I add another process over here, it will be another say step over here. I would just have to add over here, and these both the builders would have to implement it. They would be forced to implement it because it is an abstract function. Correct? Suppose if there is no graphics card earlier, like old laptops or old desktops. Now I decided I want to have a graphics card in desktop also. Then what am I going to do? I'm going to have an abstract function over here, abstract method over here, and both the builders will be forced to have that. So we have a consistency also. We are setting a template in the interface, correct? Yes. And what is that director doing? It is directing the building, right? How are we directing? Because it is actually calling that, okay, first you do this, then you do this, then you do this. So tomorrow, if my process has to be changed, if I want to build my memory first and and probably build motherboard later, where I will have to change? I will have to change only in the director. Notice, when are we using builder design pattern? When the construction process is same. What is the construction process? Build the motherboard, then build the processor, then build the memory, then build the storage, then build the graphics card. Does this much make sense? Let's look at more examples now, and then it will get clearer. Does it make sense? Okay. A lot of people are asking, why do we need director? I was planning to tell you this later, but I can tell you this now also. See, director is actually optional. Sometimes you might see code that you just want to tell that I want to build this, then this, then this, then this. You can do it in your main. Then your main or your client will itself become a director. But when you learn builder design pattern, you should know that whoever is actually telling that, you have to call these functions in this order, do this, then this, then this, then this, then this, who is actually calling the functions on the concrete builders will act as a director. It is not necessary to have a different class altogether for direction. You can do it in your client, in your main, but we want to make it as readable. We have to follow solid principles. SRP, right? Single responsibility. So who is directing the build process? Director is doing that. Does it make sense? A bit better? Yes, no? Okay, let's take some more examples and let's try to understand where else can we use it. Okay, so I got the feedback that we should use some simpler examples first. So let's look at one very simple example that is not related to, like, something that you might do in real life, but because I guess examples from Swiggy, Amazon can become a bit overwhelming. So let's take a simple example. Okay, so now suppose we are all building a house. House is something that we all build, correct? House, right? Now in this house, there are some things that we all want to do. Okay, let me move this here. Okay. So when we have a house builder, what all will be building in this? We'll be building, say, floor, build ceiling, build kitchen, some more interiors, like maybe build windows, different things. And we have to do all of this, correct? Yes, the structure is there. Now what are we going to do is, yes, walls. Okay, build walls also, but okay. Now I have different kinds of houses. Okay, so the construction process is same, it is complex and all of this is there, but I have different types of houses now. Suppose, for example, I have a marble house and I have a wooden house. Okay, I know it is hypothetical, but suppose I have an entire marble house or an entire tree house or wooden house or, an igloo house, something like that. Just this is for understanding purposes. Now, in all of this, in wooden house, I have to build floor, ceiling, kitchen, windows, all of this, but the process is different. The configuration is different. The process is still complex. It is still same. The construction process is still same, but the configurations are different, correct? Similarly for marble house also. So what I am going to do now is that I am going to have, it's better here only. So I am going to have different builders. So now what I have is that I have a marble house builder, a wooden house builder, and an igloo house builder. And what are they building? They're building a house. So this is the product. This is the builder. And now I need to call these functions: build floor, build ceiling, build kitchen, build windows. You can choose that you want to do it somewhere outside. You want to do it in main. You want to do it, on the client side. But here I am choosing to do it, like, who is going to do it in a civil engineer class. So this is a common example. It's a very simple example also. That is why I'm telling you so that you understand it properly. And the civil engineer is going to call the function construct house. And inside this, it is going to do builder dot build floor, builder dot build ceiling, builder dot build windows, and so on. And as we already know, the civil engineer will be passed what? It will be passed the concrete builder. So it will be, say, passed wooden builder, wooden house builder. Correct? So my director will have the builder. And okay, now one very important thing to understand, like this. Okay, let's understand from here itself. So our director has a builder. This is an aggregation, right? Now our builder also had product. If you noticed in the code, we will look at it again. We will have what? We will have the product. So builder, if you saw in the desktop builder, we had desktop inside this and we were building that, right? It could be outside or it could be inside this. But in short, director has builder, builder is building the product. You can think of it like this, right? Now, one very important thing that I want to talk about. Firstly, have you understood this much? Roughly, have you understood when are we going to use it? We are going to use it when the construction process is same. There are a lot of configurations. The creation process is complex, correct? Now, one thing I want you to understand is that, see, in every design pattern, there are some simple guidelines. Like, for example, there will be builders, there will be a builder, and there will be some concrete builder, and there will be director. Now, there are different ways of actually implementing this same concept. Let me tell you how. Now, in some places, because it can get a bit confusing sometimes, what is going to happen is in get builder, they will have, say, get product method. Like in that sense, I mean that my builder will have a get desktop method, and we will return desktop from here, right? Similarly, my director. Now, what happens is that my director has builder and builder has get product. So from my main, remember what I was doing? I was creating a new product and I was passing builder to it. So in some places you will see something like this, that director dot get product. So now what will happen is that you will have another function inside this get product. And how can you implement it? Director has builder. And now my builder has this get product. So I can basically just do return builder dot get product. See, I am not saying that these are some mandatory things that you will see everywhere, but there are different ways of doing this. In some places, you will see this get product, you will see the get desktop, get house and all that in director itself. And in some places, you will not see it. But I don't want you to get overwhelmed by these details. That is not important. What is important for you is to understand that what is actually happening. Understand that, okay, there is a director, there is a builder, there are concrete builders. They can be a get product because builder is creating the product. So we can either do create product or we can have the product inside the builder. So if there's the product inside the builder itself, we can do a get product. And if we want to do that, we can do director.get product. Make sense? Yes or no? Yes? Let me take one more example, one last example, let's say. Okay, let's take one more example. And this is sort of a more software engineering example, but it can be a bit hard to understand. So everyone stay with me. So in this example, you have a Word document. Okay. And now you want to convert this. You do export, right? So I want to convert the Word doc into some particular format. Now, sometimes you just want to do it, say, in a text doc. Sometimes you want to do in PDF. And there are more types, like there is one graphical format, there is RTF and all of that. So basically you want to convert these into different formats. Does everyone understand the problem, what we are trying to do? That there is a Word document, we have to convert it into different formats. It can be a text document, it can be a PDF, it can be a graphical format or anything like this. Does it make sense? This is actually one of those examples that is given in the Gangs of Four book. So yes. So I thought it would be interesting to understand it. Can I get more yeses? Like it does make sense? Like the question makes sense? Can we go ahead? Yes, yes. Okay. Give me 1 sec. Okay. So now what am I going to do is, how do we actually convert Word document into desktop or PDF or graphical format is, in the Word doc, we go through it character by character. We check that, okay, if this is my Word doc, I will go through this character that, okay, is this like bold, or is it or over here, is there a new paragraph starting, or is it a highlighted character, or is it some, particular kind of character? Is it a symbol, right? So you go through character by character. Okay, so you can think of it like this. So your code is going to look like this, that for, say, character C in this Word document, I want to see that, if my C is, say, new para character, okay, I am going to like do this. I'm going to convert into this format. Or if my C is, say, a highlighted character, I'm going to build like this. Or if my C is basically this type, I'm going to build like this. Okay. So basically this is how it is going to look. But the point is that you notice over here that the process is same. You will have to build for highlighted characters, for bold characters, for paragraph, for all of this, right? So the process is same. So the class where it is going to happen, okay? So the class where, yes, Akash, I've started the recording, relax, okay? So where we are going to actually do the conversion, where we are actually doing this is going to be a director. Okay, so director is a class where I'm going to be calling these one by one. Okay, now these are my products, right? Like my product is basically text doc or PDF or graphical format. So I'm going to have an interface, a builder. And then from this, I will have, say, different classes or abstract methods, to be precise, like build para or build highlighted character or build bold character or whatever, like some things like this. And then there are going to be concrete builders. What are going to be concrete builders? Desktop builder, text doc builder. There's going to be a PDF builder. There's going to be a graphical format builder. And there are going to be builders for all of them. And they will have to implement build paragraph, build highlighted character, build bold character. It does make sense, correct? Because all of them have to do these conversions. It can be any character, but you have to have this conversion. And if you think about it, it does make sense because a builder is doing what? It is giving you a template that these methods you have to have in order to be able to convert this Word doc. Correct? Does it make sense? So the one who is actually going to do this is going to be called a builder. Then there is one interface builder, which is going to tell that, okay, these are the methods that you have to do. Now for each type where we have to do the conversion, we are going to have concrete builders who are actually going to do the conversion. That if we want to do it into a text doc, this is how I'm going to do the conversion and this is how it is going to look. If I have to convert it into a PDF, this is how it is going to look. If I'm going to convert it into a graphical format, this is how it is going to look. Yes? Okay. Let me look at the chat for a minute and answer all the questions. Paris is asking, why are we passing in the director? It should be an abstract builder. Okay. Why are we parsing? Okay, what is abstract builder is doing? One character that the builder has gotten, we are working on that. So basically think of it like this. So our director has a builder, correct? So what we are doing is builder dot build para, and we are just passing the character in this, or builder dot build highlighted character, and we are passing the character in this. Does it make sense? So our director has builder, and builder is the one who is building the actual, the converted object, the converted format or whatever it is, text or PDF or graphical format, right? Is builder class always abstract or can it also be an interface? It can be an interface if you are not implementing anything. Like for example, if you do not have a getter, if you don't have like get desktop or, get what other is get house inside that, then you can make it an interface, correct? That is what I'm saying, that don't be don't get worried because of these small details like abstract class or interface. If you put a getter inside this, obviously it is going to become an abstract class and not an interface. But if you have no implementation over there, then it is going to be an interface, correct? Okay, let me take more questions. Is this builder pattern and Lombok Spring Boot? Okay, I'm not going to pick up this question right now. Sri Rajni is saying, unlike the desktop example, here the output of each of the type builder might be different, right? In that case, will we have an interface or abstract class for that as well? Very good question, Rajni. And this is another point that I wanted to address. So let me explain to those who are saying, see, here what we did when we build a desktop builder, I said that you can have a get desktop inside this, right? Because in the end, you are doing what? You are returning a desktop, right? Basically, your product also, because there is a desktop product. And from here, you will have, say, Dell desktop or your HP desktop or your Sony desktop, correct? So in this case, if I have a getter in my builder, then obviously my product also has to be an interface or an abstract class, right? Only then I can return, no, because I have to return the common type. But over here also, in my house builder, I can have, say, get house, right? So my house will be, my get house will be returning what? It will be returning house. Now my house can be a marble house or a wooden house or an igloo house. Basically, these are different types of houses. And to be able to return just house, obviously this has to be the base class, and marble house and wooden house and igloo house has to derive from that. So we are doing subclassing. We are doing in inheritance over here, right? So our product is also basically a base class like that will be inherited, and they will be like concrete products also. Marble house, wooden house, igloo house, correct? Versus over here, like text doc, PDF, and graphical format builder, graphical format, right? Now, what you could do is like have something like a doc and have, say, text doc and like PDF or a graphical doc from over here. And you could return, like you could, from your builder, you could have a get doc, and the return type is going to be this doc, correct? This doc. Or instead of having this getter inside this, what you can do is have getters inside the concrete builder. So you will do get text doc, get PDF, and get graphical format doc, right? So it is not necessary that you have to have a getter inside the builder. It is not necessary that you have to have a base product and then you will have to inherit from that. You can have your separate getters for like different kinds of products that you are having. But obviously, in order to make it more generalized, in order to keep it more extendable, it does make sense to make the product also as generic, to make it as a base class and have a getter. Does it make sense? This is a good question, Shirajni. I wanted to cover it. Yes? Guys, can I get yeses? Yes? Okay. I will repeat this part. Again, before I move ahead, let me repeat this, that this is usually used in a very complex system. Only when you're going to have like a lot of configuration, your constructor is going to be huge. It is going to be very, very complex. The process is going to be complex. We use builder design pattern. One of the disadvantages, as you can see, is that there's going to be a lot of code. There are like, we have like director, we have builder, we have concrete builders. There's a lot of code. So I am not asking you to force fit into cases when you wouldn't need it. Okay. So you don't need it like that. Right. And if you want to, by the way, the code, some people are asking, the code is already uploaded on the GitHub. So you can check it out. And we'll also look at it now. But a quick revision before we start looking at the code. And then there's one more point that I want to cover about builder design pattern. Okay. So I'm going to repeat it from the starting. Can I get everyone's attention, full attention over here? Please, a quick revision we'll do of builder design pattern. Yep. Can we get more people over here, please? Like full attention. Okay. I will look at more questions and I'll answer all the questions. Okay. Don't worry. If I don't answer now, I'll answer at 11, but I will answer everything. So just listen to me for now. So we talked about that there are some products and so creation process is same. There are a lot of configurations to be done. Like we talked about the desktop example. In desktop, we have to build the RAM, we have to build the processor, memory, keyboard, mouse, and all of that. The process is same. So we are going to do what? We are going to put the entire process. Where is it? So we are going to put the entire process inside builder. That, okay, build RAM, build processor, build monitor, build keyboard, and all of this. So this is an interface or an abstract class. So basically, all the builders, all the concrete builders have to have build RAM, build processor, build monitor, build keyboard. They will have to have. So a Dell desktop builder will have to build RAM, build processor, build monitor, build keyboard, right? And now, so this is the product. These are like the derived products. For those who did not understand the last point that I covered, see here, notice that my product is desktop, and Dell desktop, HP desktop, Sony desktop are inheriting from the desktops, correct? So in my builder, I can do get desktop. And what will be the return type of get desktop? It will be a desktop, right? Because that is the base type. That is the super class. Instead, if I did not have a base class, if I did not have desktop, see, why am I saying? It is obviously better to have a base class, right? We'll end up having a better code. But builder design pattern doesn't focus on that. Builder design pattern focuses that there is going to be a builder, there are going to be concrete builders, there is going to be a director. Okay, that is why I'm explaining this point to you. That if you did not have a base class for the products, instead of having a getter in the builder, you could have getters in the concrete builders. You could have getters, say, in Dell desktop builder, it would be get Dell desktop, get HP desktop, get Sony desktop. So you will have your getters in your concrete builders instead of your interface builder, correct? Yes. And I would like to, quickly before I move ahead, I know some bit of gyan I wanted to give, especially to the college students over here. Okay. What the concepts that we are learning right now are very complex. SD1, SD2, even SD2 might not be asked this, to implement the entire build a design pattern in an interview. So you are understanding some really, really good concepts. And if you understand this, you will be ready for, say, even SD1, SD2 standard LLD interviews. So it can be very overwhelming at this point, and it is fine. You are a college student, right? There are a bunch of people over here who have 10 plus years of experience. So it is okay. I just want you to put more effort and show up in the classes and try to understand as much as possible, but you will be able to understand. Okay. So just have patience and stay with me. Okay. So I said builders, concrete builders, desktop. I talked about concrete products. Then there's a director who has builder. Again, so understand this point, that director has builder. Builder is building the product. Director has builder. Builder is building the product. Director will be past the concrete builder. We will look at the code again. Director will be past the concrete builder, and it will say do exactly this. Let's look at the code once more. Okay. Give me 1 second. Can you look at the, are you able to see the code? Yes. Are you able to see the code? Okay. Let's look at it once more. Okay. The Java part. So here, see, this is the product. There are some strings. There is display inside this. There's just getters and setters, nothing else. Product is very simple. Nothing I am doing, just something is there, and there are like display and there is getter, setter. That's it. These are different configurations, right? Product, desktop. Then there's a desktop builder. Now notice over here, desktop builder has desktop in our case. It is not necessary to have. If I did not have, say, desktop, I had, see, currently, if you think about it, okay, if we go into desktop, so if we go into desktop, I am returning, say, desktop type itself, right? I could have had different HP desktop, Dell desktop, and Sony desktop. If that was the case, I couldn't have had this getter. And that is the point I was trying to make. Okay, in that case, it would be essentially become an interface because all the methods would be abstract, correct? And notice that I made this protected. Why did I make it protected? Because I want my product to be accessible in all the concrete builders. So desktop builder is my abstract builder. It's my abstract builder. And my Dell desktop builder, my HP desktop builder are going to be concrete builders, correct? So now again, notice builder has the product and it has all the methods of how to build, right? Exactly. Build motherboard, build processor, build memory, how to build. Now Dell desktop builder is actually doing the building. It is building the Dell motherboard, Dell processor, all the configurations. Similarly, HP desktop builder is actually doing the building, HP motherboard and all of this configuration. Now notice my desktop builder is past this, desktop director is past this builder, right? Another way would have been that I have my builder inside this. So it would have been like this. So desktop builder. So it would have been like private desktop builder, and I would have had builder in this. And then in the suppose constructor of director, I could have had this. See, let me tell you what I'm talking about. If suppose I do not want this like this, okay, I want a private and now a private member builder. And while creating the desktop director, you could have passed the builder. And it would have looked something like this, that this dot builder equal to builder. Does it make sense? This is another way of writing it. Here also I am building only, correct? Why is it giving me red? Because actually I am passing, right? Like over here. So what I would have done in that case is I would have actually created the builder first and then passed the builder in the director. Correct? So while creating the director, I would have passed the builder. That is one way of writing the code. This is another way of writing the code. Another way is what? The way that I have written. that in build desktop, I am passing the kind of builder that I want. So don't get confused when you see all of these different ways of, the ways in which the code is written. The concept is going to be same. Again, different thing that you're going to notice over here, the one that I was talking about. There's a return builder.get desktop over here, right? Sometimes this will just be a void and you will not be returning anything. You will not be returning anything. And you will just do this. And suppose there is a different getter, that public get a desktop. And you can do builder.get desktop. Correct? That is one way of doing it, that I don't return anything. I just make it void and I do that. These small details should not get confusing. I'm telling you different ways in which you have to write the code. And the point is that my desktop has builder. It has builder. And it is telling the builder that builder, build motherboard, build processor, build memory, build storage, build graphics card. If you look at this code, this is not actually aggregation, right? I understand that I have not added builder, and in the UML, you will see aggregation. That would be the code that I had written earlier, that, okay, I will have a private member as builder, and then I'm going to pass it. So if you see a particular UML, you have to understand it. Okay, is it aggregation? Is it just association? So you have to understand these little things. Make sense? Over here, I have done builder.get desktop because I have access to the builder and my builder has this desktop. My builder has this product. Got it? So my director has builder, my builder has product. Correct? And if you see at the demo, if you look at the main part, there's a director. And in my director, I am just telling that while building, build the Dell desktop builder. Another way would have been that I do this later. I do this over here. And over here, I pass this builder. This would have been another way. And I don't pass anything inside this. This would have been another way of writing it. That I first create the builder. Then in the director, I pass the builder and then I build it. Or another way is what I have done, which is that I first create the director and then builder, I do the new and then I pass it. Okay. The point is director is going to see the main things that you should remember. Director has to have the construction that build this, then build this, then build this, then build this. This is the important point. The next important point that you have to remember, that in my interface builder, you have to have abstract methods that are going to tell that, okay, my concrete builders have to implement these particular methods. And then obviously my concrete builders will have to implement it. Make sense? Yes, this much makes sense, guys. There's one more last point that I want to cover and then we'll be done with builder. Okay. One last point that I want to cover over here. And that is, okay, this is one way of writing the code. Okay. There's one more way of writing the same code, the same thing essentially what we'll be doing in this part. Okay. So here, when you look at the code on GitHub also, you will see there's C++ Java under builder design. You will be able to see builder with chaining. So there's like different way of writing the code. I'll just show it to you. So basically what you do is over here, you can see this is how the code is written. That in my build, how did my build look earlier? How did my build look earlier? So if I look at this build, this is how my build look, right? That builder.build motherboard, this, then this, then this. Instead of this, we can write it in one line. This is another way of writing the code. Builder.build motherboard, build processor, .build memory, .build storage, .build graphics card, .build. What is this called is chaining, because they're adding the chains. Now, how is this even possible? How are we doing this is, see, my builder should return something on which I can call build motherboard, should return something on which I can call build processor, based on which I can call memory, based on which I can call build storage, correct? So you can think of it like this, that there's a builder. On that, I am calling build motherboard. On that, I am calling build processor, correct? On that, I am calling build memory. So this is like just to understand it, I am showing it to you. Then on this entire build memory, I am calling build storage. Then on entire build storage, I am calling build graphics card. So this is called chaining. And how are we able to do this? See, over here, we were calling all of these build functions on what? On builder, right? On the desktop builder we were calling. So what I do is in all of these build, I just add one return type as desktop builder. And that is it. And we can achieve this chaining. Okay, again, I am repeating this point. Do not get confused. All I am doing is converting this code. Build motherboard, build processor, build memory, build storage, build graphics card. I am adding all of this into a chain. How does the chain look? It looks like this. That builder, dot build motherboard, dot build processor, dot build memory, dot build storage. How am I able to do this? Because all of these functions need to be called on builder, correct? So in builder, basically in the, if you see my interface itself, my abstract class itself, I have added the return type as desktop builder. Right? And because of that, because I'm returning the desktop builder, here I'm just returning this. This is basically I'm returning the same thing. Let me show you the Java code also. Okay. So here, if you see in the desktop builder, I've written the return type as desktop builder itself. Correct? So in all this, I'm just returning this. Right? So if I return this, or obviously in my concrete builders also, I will have to return the desktop builder. So I'm just returning the same object, right? So over here, what am I doing is that after building motherboard, okay, just forget about this. Forget about this. After building, like earlier I was doing this, right? After doing this, what am I doing? Like if you notice this code, right? Sorry, not this code. This code. What was I doing? I was building motherboard. Over here, after building the motherboard, I have returned my builder itself, right? And on that, I am going to build processor. And after I am done building the processor and I have the builder again, I'm going to build the memory. And from that, I will have what? I will again have the builder. And again on that, I will build storage. Again on that, I will build graphics card. Again on that, I will call build. Does it make sense? And guys, we are done with one of the most hard design patterns ever. Okay. So I do not expect the beginners to understand it in once. I definitely don't, because I took weeks, if not months, to understand this one design pattern. And it is okay if you need time to understand it. It is completely fine. Okay. But you have to think of it like, okay, we have to do the creation. The creation process is complex, but it is fixed. I have to build this, then this, then this, then this, then this, then this. Okay. And the construction process is same. I am building similar objects also. Like if I am building house, I am building like igloo house, wooden house, and this house. Okay. Whoever is asking me to compare factory builder, let us cover more creational design patterns. But after we are done covering all the creational design patterns, we will compare them. Okay. Can I expect some more patience from you? And we will cover two very simple design patterns. This was probably one of the most hardest ones. We will cover two very simple design patterns. And after that, we will compare all of that tomorrow in the starting of the class. Does it make sense? Can I get yes? Is everyone awake? We will compare factory, abstract factory, factory method, builder. We will compare everything. Okay. The code is already available on GitHub. But, okay, one very, very important point. If you want to practice UML, please, I would really suggest that create UMLs of the code that I have written. Like the generic UML that I just made, you will find everywhere. I will add that also. And try to create the UML yourself. Okay, that this is the builder. These are the concrete builders. This is the product. This is the director. Note, okay, one very, very few points, like, very, very important points that you need to remember. Product is there. What is builder doing? There is some methods that concrete builders have to implement. What is my director doing? It is telling that you call this method, then this method, then this method. So director has builder. It is calling the building process. Builder has product, and it is actually doing the building. Make sense? Director, builder, product. That's it. If you understand this much, very good. Yep. Yes. How do you feel? You have understood the toughest design pattern. The toughest. Like after this, like if you understood this, no, it will be clearer. I can see some people saying that I found it to be easy and very good. Then so everything else is very easy for you. Okay. Can I move ahead? Oh, by the way, I also said that there are two very famous applications of builder design pattern, right? So one is SQL builder. So in SQL, if you see, when we have SQL queries, right? So they will be like where clause and this clause and this clause, right? So what actually happens, if you read more about it, there's a class and there's a builder. So basically you do this sort of chaining method and you go, okay, build this and then I put this clause and then build this and then build this and then build this. Similarly, JSON object builder is also use builder design pattern. So you can imagine these are really complex objects that we create, right? SQL queries and JSON object builders. These are like really, really complex things. Like as good software developers, we should know what are the possible solutions. And suppose you did not know builder design pattern, how would you do it? You would have to have so many constructors, so many configurations. So builder design pattern is doing what? It is making your life easy. There are no many constructors. There are no many configurations. You have one process to be followed. Yes? Make sense? Cool. Can we come to the next design pattern? Is everyone ready? Is the how's the Josh, guys? Okay, I'll give you. I was thinking of letting you unmute right now, but we really have to cover 2 more topics, and then we have to it's okay. We will keep doing revision and we keep comparing. So I want a lot of energy in the comments. Let's go. Yes. Come on. I want everyone to react and say yes, yes, yes. Thank you so much. The next one, it is the easiest. You'll go like, very easy. I can definitely do this. Okay. Let's take the example that sometimes we put a lot of effort in creating something. We, did something like, suppose we use a builder design pattern and created a particular object which was very, very complex. Okay. Or somehow like while creating some product and while creating some object, like we did construct. Okay. There were a lot of this that, okay, there's a parameter and we have like that if parameter, the values are between this and this, then you do this. If the parameter value is this, then you do this. If the parameter value is this, then you do this. So basically you can understand, right? Like while creation, the process can be very confusing, that we have to do a lot of things. Now what happens when we have to, suppose we have an object one. Okay, we have an object one, all of us. And so what is the base till now? We have an object. We put in a lot of effort in creating this object. There were, say, many configurations. We had to do something, something, something. Now, I want to create another object, object 2, that has exactly same values as object 1, has the exact same thing. Okay. Now, basically what I want to do is I want to create a copy, or I want to clone it. As software developers, we all should be very used to doing this, right? Because we do Control C, Control V all the time, correct? Command C, Command V in very nice terms, right? Yes, we call copy constructor or deep copying, right? So now, basically what this design pattern says is that this cloning process that you have to do it, you delegate it to the actual, this object itself. And let me talk about this why. Suppose this object 1. Okay, so this object 1 is part of, say, this class, and the class has a lot of, say, private members. Suppose, A, B, C, D, all of this. Now, suppose I am on my main, or I am in my client side, like wherever, basically somewhere outside. I have object 1, and I want to clone the entire thing to object 2. Now, understand this, that my main or my client will not have access to these private members. Everyone understands the problem, right? That my main or client doesn't have access to the private members. Correct? And I want to create the exact copy. I do not want to go through the entire creation process. I just want to clone it and I just want to create a copy. Right? So does everyone understand what we are trying to do? Can I get yes or no? Yes? Do you understand the thing that Vinil is saying no? What, like, okay, let me just quickly repeat it. Preeti is also saying no. Okay, let me repeat it. So we have a class. We have a class. There are some there are some fields over inside this. Okay, let's say we have a menu. Okay, we have a menu, and in my menu, so I have a restaurant, and I had say, suppose my restaurant is called Keerti Restaurant, right? So Keerti Restaurant has one branch right now in Sarjapur. So I created the menu very nicely. I had some private fields inside this. What were my fields? Like, what is the, like, what can be the private fields? Like, my the images and all will be public. Suppose quantity that I have available or something like that, that I do not want to be publicly available. I want some information that is mine. Okay, it is mine. Now what I am doing is I am opening another branch from Sarjapur to say Koromangala. Okay. Now I am opening another branch. I want to create a copy of the menu. I want to literally just create the copy. Okay. Now, like I am telling this client that just create the copy and do it. Right. So when the client creates a copy, client doesn't have access to these private fields, first of all. And my client has a lot of other things to do also, no, other than doing this. So it says that instead of I creating the copy, why don't your menu itself, is able to create a copy? Basically, let me tell you what I'm trying to do is that I am going to open a lot of restaurants. Not just in Sarjapur, I'm going to be opening in Koramangala, I'm going to be opening, say, in Mumbai, in Delhi, in Bangalore itself, I'm going to open 4 more, right? So what I'm going to do is I am going to make a prototype of my menu. That this is the menu that I want to have. Okay. And every time I want to create a new object, I am just going to do what? I'm going to clone or copy this menu. How we are going to do is we are going to talk about it. But does it make sense that what we are trying to do? That I want to have a prototype that this is how my object should look like. Right? This is exactly the values that I want. I don't want to do any effort. I don't want to go through it, anything again. Just do copy, paste, clone the entire thing and give it to me. Simple. Yes. Create new object like of the same class, but with the same values. Now let's say we were not doing prototype, like we did not know what is prototype. We were doing what. So if we had to do that, what we would have done, we would have created a new menu, like I would have called it Koramangala menu. And I would have said that, okay, new menu. And inside this, I would have to set all the values again. Like I would have to do what? That Koramangala menu dot set this, dot set this, dot set this. Instead of this, once I have a prototype, I know that I'm not going to make any mistakes. The cloning is going to happen seamlessly. Plus, what is going to happen is that I can add more prototypes and remove prototypes. So I'm going to make it extendable. I'm going to make it very maintainable. So every time I want like a new menu type, suppose I have types of restaurants also. I have say a Chinese restaurant and I have say many, like I have a chain of Chinese restaurants or like I have a chain of, Rajasthani restaurants. So when I have a chain of Rajasthani restaurants, I want to have a different prototype, a different menu for all of them. And when I have like a chain of Chinese restaurants, I want to have different prototype for all of them. Does it make sense? Yes. So let's look at how the UML is going to look at. Okay, so there is basically going to be a prototype. There is a prototype. And inside this, there is going to be a function clone. So now the point is that this prototype is clonable. Right? So I'm going to call it, I'm going to make it an interface. And why am I making it an interface? Because from this, there are going to be different classes. Like there's going to be, say, prototype 1 and prototype 2. And they would have to do their own cloning, like clone 1, like clone itself, they would have to implement this clone function, correct? And my client will actually do the operation. Okay. Can I like the problem seems to be very simple and obvious, right? Basically, I just want to delegate the cloning process. Can we look at the code? Can we look at the code and let's understand what's happening? Yes, can we look at the code? See, I know we can always combine multiple design patterns. Like for example, some people might think about combining prototype and factory, or say prototype and builder, right? There are ways of combining design patterns. For now, we are understanding the design patterns from scratch. So let's look at them one by one. When we actually solve the problems, no, when we solve like IRCTC and the complex problems, we like our thought process would have been like built by then, and we will look at the complex, like how to build, how to combine different design patterns together. For now, just try to focus on prototype. Okay, cool. Let's try to look at the code. Can you see the code? Yes. Okay, so this was builder. We are at prototype. In this, I have taken two examples. So let's look at this example currently. Okay, let's look at router. So now what I've done is that my prototype is a network device. Okay, so this is the example that I have done. So 1 second. So my prototype is a network device, and I have a clone inside this. So you can see it is pure virtual, or in terms of Java, you can see that it is abstract, right? So it is abstract. So all the classes that extend, basically that implement this prototype, the product prototype, will have to implement this clone, right? Correct. So now, okay, so let's look at this. So there's a display, there's update, and all of that is there. So there's a network device and there's a router. Okay, so now my router is basically inheriting from my network device. So this was my prototype. You can call this as product. So this is my product, right? So now inside this, if you think about it, in clone, all I am doing is using the copy constructor and actually copying it. That is all I am doing. But who is doing this? My clone method is doing. So my client doesn't know that how the cloning is happening. Let's look at this. So in my main, if you look at it, what is actually happening is there's a router prototype, there is a switch prototype. So when I have to create a clone, all I have to do is tell this prototype that you create a clone and you give it to me. So my client or my main does not know what you're doing internally. You call copy constructor, you create, and you assign each of that inside you, or you actually do the entire process. I don't care. You clone it and you give it to me. Understand the point? That my client, my main, has no idea about how the cloning is happening. It is just doing the cloning. Okay, let's look at the Java code also. Okay, so here you can see in the main part, there's a router prototype, there's a switch prototype. In the clone, all I am telling is router prototype dot clone. I can see people literally vomiting that, CPP design pattern is so different. The code is literally the same, guys. This is literally in your head. Look at the code. Router prototype, there's literally an arrow over here. There's just an arrow. And all that there is over here is basically a dot. That is the only difference. I don't understand what is the huge deal between C++ and Java. There we are using a pointer, here we are using an object. Oh my God. But okay. There is a router prototype, there is a switch prototype. While creating a clone, again, my main, my client, whoever is using it, is basically all it is doing is that you clone it and you give it to me. I do not care how you do it, you do it. Okay. You can actually run all of this code. I have run it like many times and it is available. So you can actually, like, instead of wasting time, like basically there's just display, right? Router clone dot display, switch clone dot display. So you can just take the code, you can clone the code, and you can try running it yourself, right? So you can update and you can display also, right? Let's look at the code once more. So there's a network device. This is essentially your prototype. Okay. And then this is your product, right? So this is, say, your product one. And so it extends the network device and it will have this clone. So here, if you see, I'm just doing a new and I'm assigning whatever the values are there in name, IP, security policy, whatever values were there, I'm just copying it. Versus I couldn't have done this outside, right? Because only this network device has the access to these private members. Think of it. Could have I copied this Otherwise, for that, I would have to have all the getters, right? I would have to access name, IP, security policy, all of that in my main. But now I don't want to do any of that. I just want you just create the clone and give me. I don't want the access also. You just clone it, you give it to me. So how you clone it? Your headache. Whose headache? The product's headache. This is basically a clonable product, right? So this is a clonable product, router. Similarly, switch. Again, you can, okay, again, switch name protocol. So here you can see there is router prototype, there is switch prototype. Router clone, switch clone. Make sense? So very simple code also I had written. Let's look at product.cpp. Instead of router.cpp, you can just look at product.cpp also. So there is a product prototype. Guys, do you guys want me to write like run the code and show you, or is it okay? Like just showing the code is fine, or do you want me to run it and show you? Like I can run it. Okay, everyone wants me to run it. Okay, we'll run it. Cool. Let me just walk you through the code. There is product prototype. There is product. Okay, so this is the prototype and this is the product. So here you can see this is the concrete prototype class representing a product, right? So this is representing a product. And here you can see I am using copy constructor for calling. Okay, in my main, I'm doing this. Okay, let's run this. So prototype, which one do you want me to run? The product one or the router one? Which one do you want me to run? Router? Okay. So, okay, I can actually compile it also again so that you guys know that I know how to do it. Okay, so I'm going to just do router CPP. Okay. Is compiling. These are warnings that I'm just ignoring for now. And when I run it, so look at it. So this is basically the output, and let's look at it. So if you see over here, the first output was router clone. Okay, so router clone. And if you look at the values that I had passed, so this was the router prototype, right? Let's look at it properly. So this was the router prototype. Here there was router A and these values were there. And if you look at the clone has exactly same values, correct? So what if you see from the main type as a client, if you look at it, I have no idea what is happening inside. I just have a prototype and initially I configured my prototype. So this is helpful how, like whenever you're setting your menu, like whenever I'm setting my menu, I will set a prototype for say Rajasthani menu, for a Chinese menu, for this particular type of menu, or say this router prototype or switch prototype or this prototype, that prototype. And later I can just clone it, right? All I have to do is do router prototype.clone, right? And when I display it, you could see that all the details were there. Similarly for switch, whatever was there in the prototype, same thing. I'm just basically nothing I'm doing inside the clone. I'm just doing it copy pasting. Correct? We don't need to know what you know. Correct. Yagni. Yes. Why this much complex code? I agree with you. But see, right now, all I am doing is using copy constructor and doing it. Just imagine and just cloning it, right? So just imagine if there was a very complex process that was involved, and every time, like menu itself, just imagine creating a menu every single time. For menu, you just don't add the dishes. Within dishes, each dish has a description. It has an image. You have to add like price and like ingredients involved, and probably the rating, and there's like a lot of things that you have to add, like while creating a full-fledged menu. Imagine creating a whole menu, and then every time you create it, you would have to go through it, you would have to see that okay, whatever values I passed is done properly or not. Basically, you do not want to check it again. You say that I'm going to put a prototype and I will never worry about it again. I will just create a clone and have it. Yes. What if I have it and I want to tweak some parameters? You can have some setters and all of that. There are also options of having custom parameters in some. You can have setters and do all of that, right? So I am sure we can change that. But my point over here is to discuss like why are we actually doing this? What is the need of this, right? Let's run Java also, because for Java, let's run the product one, right? So CD. Java, and let's run the product demo one. So here you can see, let's look at the Java code. Okay, so here you can see there was a product prototype, there was a product, and there was name and price, right? In display, we are just displaying the name and the price. So in the demo, just look at it. So the product one, okay? So in the product one, what did I pass? Laptop and this. And when I'm creating a new product from this clone, and when I am printing it, see, this is my original product. So these are my original products and these are my cloned products. So it's just basically the same thing, right? Because I'm just copy pasting. So original products, clone products, same thing, copy pasting. Yep. Yes, you can do student A equal to S. Yes, basically you can do new product one equal to product one. You can do it over here, but not always the copy is going to be so easy. Firstly, you might want to customize it, right? Secondly, like there might be a whole lot of process that is happening. And again, SRP, you want to just delegate the cloning process to the object itself, to the prototype itself. Do not want to do it. See, I agree that this is something that you might not use like in a lot of systems, but these are basically the guidelines. This is something that is used when it is a very complex object and we do not want to create a copy again, right? Okay. So what are the main points to remember over here? We have to create the exact copy of the object. The object fields can be private and that is why not visible to the outside world. We want to delegate the cloning process to actual objects that are being cloned. We do not want to do it. That is the main point that we are trying to do. We are creating the objects, but I don't want to create it. You create it. Like whoever is getting cloned, I am delegating the cloning process to that object itself. Okay. So we have a common interface, which is the prototype. And then there are like proper, the products that are formed from the prototype. See, again, let me repeat that there are going to be dozens of fields and hundreds of possible configurations, right? So when we clone, we are just giving the headache to the prototype and we are not caring about it. Okay. Does it make sense? And also, by the way, one very good advantage that we can add and remove products at runtime. Okay, let me share my screen. Give me 1 sec. Can you see my screen? Okay. So if you look at this, if I add another product over here, or if I remove this one, it is going to be seamless, right? Which solid principle are we following, right? We can have new objects also with different prototypes also. We can keep adding new prototypes. If we want to use it, we'll use it. If we want to remove a prototype, I don't want to have any Rajasthani restaurants anymore. I'm just going to delete the prototype. That's it. Yes, OCP. I can see a lot of people talking about it. Yes, the disadvantage is that the lines of code is huge. It can be an overkill for a project that uses very few objects. It has to be useful, obviously. And when we take such simple examples, it might not be very easy to understand. Again, I am telling you that right now we are understanding the concepts, but when we discuss complex systems, like when we are going to discuss IRCTC, the recommendation system, when we are going to work and very complex systems, we will start thinking of these possible solutions. For now, your focus, your thought process should be what problem are we solving? How are we solving it? What is the focus? What problem are we solving? Who is solving it? Builder design pattern. What was the problem that we were solving? That same building process, many configurations, very, very complex process. Here, what are we solving? We are just cloning the same thing and we don't want to do it. We want to give the work to someone else. We want to delegate the cloning process. No break, guys. Sorry, Pratik. One last design pattern to cover. But this is probably the most important design pattern to cover, like in most important creational design pattern to cover. even more important than the factory one. So factory design pattern is very important, but this is even more important. So I will want you to think about it. I know on the first day I said we will take examples of Uber, Swiggy, and all of that. But then a lot of people said on Discord that we want simpler examples while understanding, and we'll take harder examples when we actually look at the code, when we look at the complex systems, right? And that is why I'm doing this. So yes, I can see a lot of people already guessing the pattern that we are talking about. But let's first try to understand the problem that we are trying to solve, and then let's look at the pattern. Can I get full energy? Can I get thumbs up? How's the Josh? Come on. I want to see more. Yes. Just the fourth day. See 3 design patterns in a day, guys. You will be like so proud of yourself. Just half an hour more, you'll be done with 1 more design pattern. And then after that, you'll be proud of yourself because you understood 3 design patterns in 1 day, right? So yes, we are the designers. Roaring, all good. I see only 5-6 people commenting on the chat. Come on. What are you doing? Sleeping or what? Chat, come on. Yes, 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 yes. Awake. Yep. Good. Happy to see. Very good. Thank you. Okay. Let's focusing hard. Very good. Okay. Let's look at the problem that we are going to solve now. Okay. The problem is, say, suppose we are doing LLD, right? Low level modules. So there are going to be a lot of modules that we are going to be working with, right? Suppose you wanted example of Uber, Ola, Swiggy, Zomato, right? Suppose there will be one order related module. They will, like in order itself, there's a complex thing, right? There are going to be many classes. Like one module is going to take care of this. Delivery is going to be another module. Probably some other module is there, right? Some modules are there. Within this also, like there can be some modules and all. Yeah, you can talk about it like package or like, like in real life, like teams, like, sub problems of a huge problem. Like you are not going to start solving Swiggy together, right? You're going to have sub problems to it. So suppose there are different modules. Now, you want one configuration for all the modules, that if I change this particular field, it should change over here, it should change over here, it should change over here. Guys, don't confuse with high-level system design. We are not talking about microservices. We are talking like low-level system design itself. They can be like some modules, right? That there are different things that we are taking care of, right? So don't talk about microservices or high-level system design. Focus on low-level system design. We are doing low-level system design, code-wise, correct? So, okay. Cool. So we have different modules. Let's look at one more example. Suppose I am building like UI, okay? So I have different modules. For example, say sub problems, right? So say I have one courses wala part. Suppose I have the literate store, correct? So I have like the literate store wala part. Suppose somewhere I have say demo classes wala part. I have different like modules. These are like different sub problems that I have to solve for my side, different UI, right? But now I want one configuration, suppose light theme or dark theme, which was actually there on my site earlier. I removed it. If you saw it on the first site, like if you signed up during HLD, you must have seen it. I removed it later. So once I set up light theme or dark theme, it should change everywhere. Courses, literate store, demo classes, everywhere it should change, correct? It should not happen that, oh, I changed in the courses, now I went somewhere else and it is now the previous one. I changed to dark mode over here, I come back, it is light mode. Obviously not a good experience, right? Similarly, in different modules, if I want to say that suppose I am not working right now, like, the restaurant is not available, all my modules should know, my restaurants should know, my delivery partners should know, everyone should know. It's a configuration, right? So configuration basically is one such problem, right? Now think of it like this. If I have different objects of configuration, say I have say config 1 object, I have config 2 object, I have config 3 object. Now every time I make change in this object, I have to make sure that I make this change, make change in this, make change in this, and then I should make sure that before the read happens from over here, like, I make it sync, like I make it at the same time. I make sure that, they return the same values. Instead of doing so much of matha pachi, aata machi satakli, why can't I just do one config object? One config object. Whoever uses this, my courses, TLS, demo classes use one config object. My delivery, my this, one config object, exactly global. Make sense? Right? Similarly, let's look at one more example. Suppose I am logging. Obviously, we all have to log, right? So we have a logger. Now we log things to files, right? Suppose I have logger 1 object, I have logger 2 object, I have logger 3 object. Now this logger 1 nicely goes and writes to file 1. This logger object nicely goes and writes to file 2. This logger nicely goes and logs to file 3. I am lost while trying to understand what went wrong. I will go to this file, I will go to this file, I'll go to this file. I'll probably have to merge it. I'll have to compare the timestamps. I'll have to look at what happened, then what happened, then what happened. Or suppose you will say, one very simple solution is that all of the files, logger 1, logger 2, logger 3, all of the objects should all write to one file, same file. But again, then what will happen? Logger 1 wrote something, was not done writing, logger 2 starts writing from there. Was not done writing, logger 3 starts writing from there. Then logger 1 says, hey, why did you stop me? I will start writing again. Such hotspots, I will never be able to understand what the hell is happening, right? So that is why I want one logger object. I do not want multiple logger objects. Very common problem, no? That is why, see, factory and singleton, two creational design patterns that you can fit in literally every design pattern. Simple factory and singleton. Literally every design pattern you can fit it. Any interview, no, whenever you're doing creation, if you think you will need a singleton object, I will show you so many examples. You open Swiggy, Zomato, Uber, Ola, anything, you will be able to see so many singleton classes. What is singleton class? Basically, the one which can have only one object. We are going to talk about how we are going to implement it. Okay. That is why simple factory and singleton, most important in terms of interviews. Like if nothing else, within 45 minutes, you can very easily implement like both singleton and factory design pattern. In simple factory, what you would have to do, you will just have to create a factory and you will have to write FLs inside the factory. Simple factory I'm talking about. I'm not talking about factory method or abstract factory, correct? Singleton also, we will look at the code, and once you understand the code, 5 lines of code. Like in 45 minutes interview, it will take you 10 minutes to write simple factory code and singleton code. So that is why be smart about it. See, builder and prototype and all of this is very, very important in terms of like understanding what is happening in very complex systems. But when it comes to interviews, we have to be smart. We have to understand what design patterns is going to help us in interviews. These are very simple to understand, very simple to implement. 45 minutes interview, you can implement 3 design patterns. Very impressive. Your interviewer is going to go like, very awesome candidate I had. Implemented 3 design patterns because knew what we were talking about. But we also have to understand that we don't have to force fit the design patterns, right? Understanding what I'm trying to say? Yes, no? Yep. Guys? Okay. So we understood the example of configuration. We want one object. We understood the example of logger. We want one object. There's another example, very famous one, which is DB instance. So basically, we want only one object to talk to the DB. So we will obviously have a DB and we'll have to connect to the DB, right? And we do not want multiple, like even if we want multiple instances, we want fixed number of instances, which is called a pool of objects. We'll talk about this in detail tomorrow. But basically, when you do not want, like, suppose there is one DB and then there are 100 instances connected. Now, one instance is saying write, one is reading, one is saying write, random information we are putting in and taking out. And we have no idea what instance, who is creating, who is doing what. Okay, so we'll talk about this more in detail. But now have you understood the problem? Can we talk about how to implement singleton design pattern? Everyone understood what is the problem that we are trying to solve? We want one object of the class, single object of the class. Make sense? Yes. Single object. Sorry. Single object. Oh my God. Single object of the class. This is the most important point of Singleton. Okay. Now, when I want to create a single object of the class, everyone with me, right? Everyone understood, right? I'm going to talk about how to implement it. I'm going to talk for 10 more minutes. I'll let you go. We'll look at more in detail tomorrow also. Okay. Yes. Okay. Now, when I want a single object of the class, first thing I want to do is to make sure that no one can create more objects of the class. Correct? I should not be like you should not be able to create more objects. Yes, I want only one object to be there. So easiest way to do is whatever is your constructor, make it private. Private constructor means what? No one else can call it. Right? Not only just a normal constructor, default constructor, your copy constructor, your copy assignment operator, all of these things, make it private. Why? So no one will have the access to create this, to create the object. Yep. Now, next thing. I want only one object to be returned everywhere, right? So I will make an static instance. I can see a lot of people already talking about it. Very good. So basically what happens when there's a static instance? When there's a static instance, this instance will belong to the class, right? It belongs to a class and not to a particular object of the class. So that is why this particular instance I can return anywhere. It's okay if it is not clear right now, it will be. Don't worry. We'll look at the code and Singleton, we'll look at so much code. No, you like by the end of the course, in your sleep also, you'll be able to tell the code. So don't worry about it. Okay. Yes, Mithun, don't worry. I'll explain the multi-threaded implementation also. Just relax. Okay. So constructor, we have made it as private. Then we have created one static instance. Now we have already made the constructor private. How do I access this static instance? There is one instance, I know that, but how do I access this static instance? Correct? Yes, how do I access this static instance? For that, I'm going to have a static getter that is going to return the static instance. Okay, so these three things and your Singleton will be almost done. We'll look at the code also. Does it make sense here? Till here, does it make sense? So if we look at it in terms of code, it is going to look something like this. So I can call it Singleton itself, the Singleton, or you could call it anything, manager, configuration, your DB instance, your what other example we took? Config and logger. Okay, right? So whatever class is there, basically we will make the constructor as private, right? So constructor private. Second thing we will do, static instance, right? So it will look like something like this, Singleton, right? You can make it private itself because there's going to be a public getter. So there's going to be basically get instance, and this is going to return you. This is also going to be static. This is going to return you the object. Okay, my handwriting is very bad. Let's look at the code. Let's look at the code instead of me writing this. Give me 1 second. Can you see the code? Okay, payment gateway is yet another example because we want one payment gateway, right? We do not want multiple payment gateways. So if you look at my YouTube video, that one is basically focused on logger. I think I implemented logger over there. Here I have done on payment gateway. Okay. So this is the class. You can see that private. So this is the constructor. Payment gateway manager is initialized, but this is private, right? So no one can call this, right? But obviously we have to call it sometime. We have to have this instance, right? The first instance, we have to have it somewhere, correct? Ignore this mutex and all for now. We'll get to it later. Just for now, focus on this. So there is a private constructor. And there is a static instance which is of the type payment gateway itself. So if you look at the Java code also, there's a payment gateway manager. This is again private, so the constructor is private, and there's a static instance of the type gateway manager itself. Okay, and then there is get instance. Okay, I know the code is very overwhelming right now. For now, ignore all of this. Ignore all of this. Look at just this. Does it make sense that if whatever instance was there, if it is null, then you create one, otherwise you return the same instance? Does it make sense? Whatever instance was there, basically only if it is null, I'm going to create a new one and send it. Otherwise, I'm going to return the same thing. Does it make sense? This much? Yes? All the beginners can understand? Yep. Okay. So here you can see in the main, what am I doing is payment gateway. I am saying get instance. Now here you can see I did not create an object of payment gateway manager anywhere, right? In C++ also you can see it. Over here, you can see that I am doing this, like I am accessing from the class, right? Get instance, right? So guys, it is only the syntax is different. Like here there is this operator there that was not, right? Here you can understand that I'm calling from the class, not I've never created an object of payment gateway manager. Okay. Here also, when I create another instance, both should be same, right? So I'm checking if both are the same. So if you actually run this code, you should be able to see that I'm creating the same instance all the time. I hate seeing errors, so I'll just undo it. Let's run it and let's see it once. I know it is 10:52 and I know we already covered a lot. So we'll look at the multi-threading scenarios and the problem with all of this tomorrow. Let me just run it and show it to you. Okay, let me run the CPP code of this. Singleton, design pattern, C++, payment gateway. So, okay, let me just run it also. So PG, I'm calling it, and payment gateway.cp. And when I run PG, you can actually see first what happened, that when I did get instance, the thing was called, the constructor was called, right? Because if you go into the get instance, forget about all of this for now. Forget about all of this. What was happening was that is a multi-threading scenario that I will talk about tomorrow. If instance is null, I'm going to create a new manager. Otherwise, I'm going to return the same thing, right? So it is initialized the first time. Then I process the payment. And I created yet another instance. So if you see, I created yet another instance because I did get instance. But it did not create another instance, because otherwise I would have called payment gateway manager initialized, right? That did not get called again. So that means that both the instances that were created are actually the same. This payment gateway and this another payment gateway. If they are same, only then I'm going to output that both are same. Correct? So even though I called get instance again, it returned me the same instance, and it makes sense, no? Because the next time I went, instance was not null, so I just returned it. So only the first time when the instance was null, I'm going to create a new instance. Otherwise, I'm going to return the same instance, right? Without multi-threading also, like I removed some code, right? If I remove that also, you should be able to see that this is working. Okay, same, both instances are same. Singleton pattern is working. Now what we are going to do is, I don't want to overwhelm you. So tomorrow we will understand that what is the problem with this, whatever we have seen so far in Singleton. Like it is working right now, right? But in Singleton, there's a very famous case that doesn't work. Like, so for multi-threading, it is not going to work. So tomorrow we'll understand why, and we will also look at how we can change the code. It is not going to take much time. It is going to take 15 minutes max. We're going to start at sharp 9. By 9:20, I want like 9:50, 9:20 Singleton to be over, so that we can start looking at behavioral and structural design patterns from tomorrow. Does it make sense? Everyone with me? Yes? Okay. Now I am basically, the class gets over. Let me do a quick revision, and then I will let you do, I will let you unmute yourself and talk to me, and then we will continue tomorrow. And okay, homework time. Let me tell you the homework. Okay, everyone, listen, do the homework. So on Friday, I'll give you like proper homework. You will have to write like a lot of code over the weekend. over like right now, because I know you wouldn't have much time till tomorrow. So just take out 5 to 10 minutes and do this. That think of the system, think of these systems. Think of Swiggy, Zomato, Uber, Ola. Think of say parking lot. Think of elevator system design. All the famous low level system design. Just write it on one page and think of all the objects that you're creating. Let me share my screen and actually write this. Give me 1 sec. Okay, someone else started sharing the screen. You need to stop sharing the screen. Okay. Anyway, you can see this, right? You can see my screen. Okay. So now what I wanted to do is note down all the important low-level system designs that you need to know in terms of interview and in general also. See, think of all the systems, like start from parking lot, elevator, think of IRCTC, think of Book My Show, think of Uber, Ola, say Zerodha, think of Swiggy, Zomato, Amazon, right? For all, or Myntra, for all of these systems, I wanted to think about what are objects you're going to create, right? We all know that there is going to be, you are going to create a lot of classes and objects, right? So I just wanted to think about the different objects that you will be creating and how you would create that. So we have discussed 4 creational design patterns, right? And these are the creational design patterns that we are going to use. I know there would be so many, but then I wanted to think about it. What are the different objects that you would create and how would you create it? Let me give an example. Like, for example, Swiggy, Zomato, if I think of menu, now I can say that I would use factory design pattern for creating different kinds of menus, say breakfast menu, or lunch menu or dinner menu. That is one way. Now you can argue with me, but the objects that you create are actually same, but my configurations are going to be a lot. So you could say I could use I could use builder design pattern, or I want to clone my object, so I could use prototype design pattern. I could create prototypes and just clone that. Or you can argue that I want a single menu everywhere. So I'm going to use Singleton design pattern, right? Similarly, just start thinking of different objects that are going to be there in the famous design patterns. So what will happen is that we'll start thinking and start, like, you probably make like a on your GitHub itself or on a Google sheet, on Google Doc. Just share the link in the sheet also and in the homework channel also, and discuss about it in the homework channel. So all of us will keep thinking, right? We will question each other. Why would you use Singleton design pattern over here? Why would you use factory or factory method or abstract factory over here? Why would you use this particular design pattern over here? Okay. Once we learn more design patterns, we should not forget the other ones. Now, today, what will happen when you start thinking about it more? Tomorrow, when we compare them, it will be easier for you to understand, right? After we cover Singleton design pattern, we will cover these 4, 5 design patterns that we have covered so far, and we will be able to understand it. Okay, for this case, this makes sense. For this case, this makes sense. Correct? Everyone with me? On a high level, factory design pattern, when you're creating similar type of objects, right? Then you have to understand that you want to delegate the process, not just from factory. You don't want the factory to be changed, so you want to add subclasses over there, different factories over there also. Factory method, you can say I want to create factories of factories. You can use you can use abstract factory method. When your creation process is very complex, when there are a lot of processes to be followed, but the processes are fixed, that build this, then build this, then build this, then build this, build a design pattern. When you're cloning something while creation, prototype design pattern. When you want only one object, Singleton design pattern. You guys have already learned so much. So all of you, give yourself a good pat on the back. You should be feeling proud. And creating objects are very, very important in any system design. So now 4 class down, you are able to think of how to create any object. And that's a huge win for all of you, right? and we are going to practice a lot in all the system design, so it will be clearer, and we are going to practice this a lot, but I hope you have a sense of what is happening. Okay, I know I'm talking a lot now. I'll let you unmute yourself. I am done. Give me 1 second. Okay, now I guess you all can. Oh, by the way, we are on Zoom today. We will have good gallery view. Can you all please open your cameras? I would get to see all of you together. Can you all open your cameras? Can you all switch on your cameras? I'll give you 2-3 minutes. Let everyone switch on their cameras. How was the class, guys? Was it okay? Cool. Overwhelming, kya?
Keerti, one question I have.
Was it
In the
overwhelming?
chat also.
Or
Hello? Hello?
so many familiar faces from HID. So happy. Okay. Thank you so much. Like, it is nice looking at you guys because it is like I am talking to a camera, to a laptop all the time.
Hello.
Ask me, how do I do that? I look at the camera and I talk non-stop for 3 hours. So, yes.
Hello.
Can you all listen to me? Can you hear me properly? Oh, wait,
Yes.
I'm not hearing. Sorry. Oh, Amit just told me that I can't hear. I was on mute. Sorry. Yes. Now I can hear.
Hello.
Yes.
Yeah,
Hi.
hi Keerti.
Hi.
Can I
Yeah.
ask one question? Actually, when I wrote the Singleton pattern in the interview, like the interviewer asked me about the lazy initialization concept. I don't know about that thing. Can you take up tomorrow that thing?
So this is what we were about to cover in Singleton. Next,
Okay.
we didn't do it today. We'll be doing it tomorrow first thing, like at 9 itself.
Okay. Sure.
Yes. Okay. So we'll be
Thanks.
covering the eager initialization, late initialization tomorrow. We'll understand how it impacts in Singleton. But guys, we've already done so many design patterns, 4-5 really, really important design patterns. Like, are you guys like, whoa, what? This is too much, or is it okay pace? Like, is it overwhelming? Like college students, especially? Is it like what is happening?
A quick question, Keerti. So we have formed these groups, right? Are we going to do a group project and implement all these design patterns?
Yep. I will give you a proper group project on this Friday because I know today and tomorrow you guys are not going to do it. So that is why I gave you the simpler example, like simpler homework. Friday, I'll give you like a proper one system that you'll be building till the end, like till the end of this, and like you'll have it ready. You can put it in your resume, you can share it on LinkedIn, whatever. So, yep, you'll have one end-to-end project ready. But
and that will be presentable to like a GitHub open source project.
Yeah.
Okay.
Yeah. But it will obviously be useful only if you guys really do it. If you guys don't participate in it, it is not going to be helpful. Okay, I'm going to record a small video. Can I get? I am so happy to see finally Zoom. Can I get? Yes. How was the class, guys? Okay. Cool. Thank you so much. And please take rest. Please, rest well. Please show up tomorrow, day after tomorrow at 9.
Questions.
Yeah, tell me.
Okay, the first one was the house example that we took in the builder design pattern, right? So that was we used the builder design pattern because we considered all the houses would have the same type of, all the houses will have the same things, right? Now, if we consider that some houses have pools and some do not have pools, the properties differentiate, then we'd like to go with the factory design, correct?
Yes. See, when you have to customize it a lot, obviously it doesn't make sense. In Builder, the main part is that, it should have the same construction process. And that is why we will compare it also, like more tomorrow. We'll look at the examples and we'll understand that does factory make sense in this or does it not make sense in this? And if you remember the starting, the first thing that I told in desktop, like if there's Dell desktop, there's HP desktop, there's Sony desktop, we can do it by factory. Why are we using Builder? Because it has the same building process. And only if the building process is same, then it makes sense to do it. Correct?
Yeah,
Then it makes
correct.
sense to use
Correct.
it.
So one more thing, right? Let's say all the desktops have the same property, but tomorrow I have a new desktop type, let's say BenQ, wherein I have a separate property, right? Like a new property, and I do not want to implement it in the older desktop version. So what do I do then? Then
Interesting problem. Interesting problem. I do not like, I want to pick up all of this, but not right now because I can see that a lot of people have left. This is exactly what I want you to start thinking about, and we'll cover it tomorrow.
okay, and one last thing that I have is we discussed the Word doc example, right? So in the Word doc example, like we discussed that we're not using get product because the type of Word doc is different, right? I mean, the return types are different. One is PDF, one is text, and one is graphical things, right? So if I want to create something in a real world example, what I was thinking was, just correct me if I'm wrong, I would have a iFactory that would be basically my product doc that would be, I mean, and the child classes would be, which implement the iFactory, would be Word doc, PDF doc, and any new type of class that I want to add tomorrow, right?
Right.
Let's say graphic and all that stuff. These classes would be having would be performing operations of giving it the right extension, giving the document a name and things like that. And then I would I would have a builder, a Word doc builder, or whatever you want to call it, that will actually be returning. So my builder would be it would
The
be
interface of the product that you create.
yeah, the interface of the product, and director would actually be so builder would be returning the interface, and director would be creating the concrete classes, I mean, objects of concrete classes.
Correct.
So is that right? I mean, combining these two this way,
So
or
okay. So you just mean that either we can have like a doc, like, and then text doc, and like these three will come like derive from that, or we can have three different, right? So that's what you're talking about, that they will inherit from a base class, right?
yeah, basically my point is that instead of returning, instead of, I mean, whatever output I get, PDF, doc, graphic, whatever, I just return it to the iFactory, and factory will take care of creating the class.
Creating the class. That is a very good thing. Can you also try writing the code? I would love to see the code also. Like,
Yeah, I can try that.
so the code is already, like, this code is already there on GitHub, right? So you can just clone this and you can try making the change and see that how you can combine both the concepts.
Okay, sure.
Yep. And tag me. I will definitely review this. This is like good thought process.
All right, sure. Thank you.
Keerti, can you please explain a bit about static once again? And one more thing is, like, I heard that wherever we use static, it is not thread safe. We need to synchronize that. I'm not sure whether it is correct or not. Can you please explain about it?
About thread safety, we'll cover tomorrow when we'll talk about singleton thread multi-threading. But about static, whenever we want a method to be particular to be a class, like for example, let me give you this homework that you can think about. Suppose in the singleton one that I am thinking, or like you want a single object, correct? How will you know that what are the number of objects that are being created? For that, let me tell you what you can do is, you can have a static counter. Like I will have a static integer variable inside it, and outside. So basically, because it is static, it belongs to the class and not to any object. Let me explain it. Let me share my screen. Give me 1 sec. Okay, I left it. But okay, let me tell you like this. So basically, you will have an integer static variable, and inside that, what you will do is, initially, like globally, you will put it to 0. Okay, I will show you the code also tomorrow. Now, every time you increase the counter, say I increase it to 1 or 2 or to 3 or to 4, even if you do it from different objects, okay, the value is going to increase from 2 to 3 only and not from 0 to 1. So suppose, let me explain it to you like this. If there's one object 1, there's one object 2, object 3, object 4, like this. There's one static counter. Now my object 1 did plus plus, so the value should have been 1. If in the objects I do plus 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 only one time, and the initial value was 0, it traditionally in all the in like normal variables, you would expect the value to go from 0 to 1, like in object 1, object 2, object 3, or object 4, correct? But because this is static, it belongs to a particular class and not to an object. So when you do counter plus plus in object 1, the value is going to become 1. In object 2, it is going to become 2. because the value is same across all the objects. It belongs to the class and not to any particular object. Then in the object 3, it will become 3. In the object 4, it will become 4. When the value is static, it belongs to the class and not to any particular instance.
But what was the question?
What is static?
Was this the question?
Yeah. He asked me to explain static only.
Yeah.
Thread safety.
Yeah.
Along with that, thread safety. That will
Only one thing I would like to add here. From C++ 11 onwards, the static objects are by default thread safe. We do not have to do anything for them.
We'll talk about thread safety tomorrow when we talk about Singleton.
So, Keerti, would you be able to give some kind of introduction or something to GitHub? I'm totally new to GitHub. If I want to start a project this weekend, it would be great to have some resources to get started.
If I send you some links, will you be able to check it out and let me know if you are stuck anywhere?
Yeah, I can do that. Yes.
Okay, I'll send it to you. Can you remind me on doubts or somewhere, like on the doubts channel on Discord? I'll reply and I'll send it over there.
Sure. Thank you.
One more question, right? Can you share your screen? If not, just look at your screen in the UML diagram for prototype. Yeah, we created a prototype interface. And then we basically wrote objects underneath it, and we marked it as a relationship of, the abstract class relationship that we have, right? How do we, if I'm not wrong, we do not denote the objects in UML, do we? We write objects under the class name itself, right?
So in that case, we also created different class. No, so it is not just different object. Like I had created different classes also, right? So give me one.
Clone A, clone B, no?
Let me just check. Give me 1 sec. Let me just check my code also, what you're talking about. So there's a prototype interface, there's prototype 1 class and there's prototype 2 class. So it is a class that I'm talking about, not the object.
Okay. Sorry, I'm bad.
So in this prototype, don't you think that the prototype is exposed to the client side? Because there I saw that all the parameters are being passed in the constructor of it. Or
No,
is it
the client is the one who is creating the prototype and then cloning it, no? So client itself is the one who creates the prototype and keeps it. Obviously, like you could decouple it even more that someone else is creating the clone and someone else is using it. But prototype design pattern essentially says that you can clone the prototype and the cloning is going to be taken care like inside the class itself. Like in the prototype itself, there will be a clone method that has to be implemented. So like it doesn't say that we are decoupling who is going to create and who is going to actually clone it, but like it is okay if the client itself does it. Like because say, for example, I am creating those menus, right? So I am only creating the prototype and I am only say creating new menus, right?
Yeah, okay. And if we are not doing it with client, then it becomes a factory plus prototype based DB.
So this is interesting, guys. I actually wanted to start combining, like as someone said, factory plus prototype, or builder plus like prototype or something like this. Can you try thinking of combinations of design patterns now, and then we'll talk about this more. Yes, doubts are also important.
Keerti, is this prototype follows ISP pattern, ISP solid principle?
ISP, okay, you tell me what is not happening. What does ISP say?
We are not forced to implement the methods that interface or abstract class define.
Sorry. What? Can you repeat that?
We are not forced to implement any of the methods as per interface or abstract class.
No, that is actually wrong. No, we should be forced to implement from interface or abstract class. What does ISP say, guys? Who is going to tell me? What does ISP say?
A class should
interfaces should be small enough so that
but what should not be forced to do what? Like
so basically a class shouldn't be to perform operations or have methods that it does not need.
That it does not use.
Right. So if there are obviously if there are interfaces are setting a template. So obviously we are forcing some classes to implement particular methods. Like in prototype, there is clone, correct? Like this in even factory, they can be like create or they can be like build in builder interface, correct? So all of these are templates that we are forcing classes to implement. So that is okay, but we should not be forcing to implement something that we do not need. That is what ISP says. So we are not doing that, right? Whose question was it?
Yeah, let's say in the product example that you have taken for prototype, let's say for some of the products I want to use clone, and for some of the products I don't want to use clone.
No, see, it is a prototype. Again, if it is a prototype, you have to have a clone function, like because it is a clonable object, right? So otherwise you don't create a prototype of it.
Okay. If
You
all
can
the
think
objects
of
needs
it-
clone, then only I'll be including in prototype.
Yes,
That should be the motto.
yes, yes.
No, but
You
isn't
can-
this question wrong? Because we're talking about objects and a single class here. How does ISP is invalidated? Like the class has only one function, that is cloning, and other function that it needs.
See, but again, like I guess you have the same question. Just try looking at the UML once more, because there's prototype interface. There's prototype 1 class and there's prototype 2 class. There can be different classes, also different types of prototypes that inherit from prototype interface, correct? So in that case, I guess she was talking about ISP, no?
Keerti, I can just give you one example for prototype, like while doing this project. So let's say I want to share the state of my object to another layer. At that time, what we do is we create a clone so that I get a copy of it and then I share it forward, like value objects, which you got VO, if I'm not wrong. So when you create, let's say I want to just create a copy and put it into a report. Let's say I have done a transaction. Now transaction is still going on, but I want a state. I want a dump as a now. So what we do is we just copy the prototype, like we copy a object and then move it into a report. So now that value gets, like, at that point of time, I get a value of the object. Now let other things keep on changing, but I have now got the snapshot. So when I have to take a snapshot, I just take a copy, make a prototype, like clone, like what you said, clone. I can just clone it and then put it, and then read it or put it into any format.
This is a very good example, but I'll tell you why I did not take it.
Hmm.
Because see, when you start talking about states, people are going to get confused about behavioral and structural design pattern, right? Right now, the focus while understanding prototype design pattern should be on creation that you're creating. Suppose you're creating the snapshot of a state, right? So this is a correct example, but the focus should be that you're creating a clone, like you're creating an object, right?
Okay, yeah, okay.
We'll discuss all of these applications definitely, like in the coming classes. But right now, I want everyone's focus to be on creation. Like, what are we creating right now?
So then when using creation of prototype, then if it is a copy, then why can't it be referenced, the same object?
Just a difference here, right? Just a question here, a different approach. If you're talking about different layering and snapshotting, I don't think prototype is something that we want to use there, right? Because as soon as we're talking about different layering, we're talking about the scope of the object. How many clones we create, all the objects are coming from the same class, right? The scope remains the same. So as soon as we move to a layer 2, we lose the object or the scope or whatever. Isn't that right?
Mani, do you want to answer that?
No, see, I'm not that technical. See, point is, I wanted to understand that what can be an application of a prototype, right? So now I was coming from that perspective that now if I'm copying a prototype, then why can't I reference it? Why
a very simple example I can think
will
of.
change the other. That's why.
I can think of prototype is report card of a class where everything will be same, only the values will be different for all the students.
Correct.
But that is the class itself, no? Object, we are not talking about prototype.
If you do referencing, then what will happen? Like anytime you do a change in the one which you have cloned, right? Then the original one is also going to be changed, isn't it? If you have referenced it. But you don't want that, isn't it? You don't want the change to be happening in the first one as well. You just want to, I think you need to see the difference between copy by value and copy by reference. So it should be copy by value, not copy by reference, right? And also one more thing, which I think many of us may be underestimating is Keerti just have given the example of cloning. Let's right, but in the prototypal structure, you can do other stuff as well other than cloning, right? So my concept in there is, let's say I'm coming from a JavaScript background, so you might be able to relate it in different languages as well. So let's say I want to perform a task, like let's say I want to join two arrays or something like that, right? And I have 10 different ways to do it. So I can do simple like create a new array, I can join two arrays or convert it or whatever it is. Like I have 10 different ways to do it. But in your whole app, if somebody is coming and then seeing the implementation of it, you don't want them to do it in 10 different ways, isn't it? For managing the whole app or something, you want them to do it in a specific way, like the way which you have designed or which you have already mentioned that this should be done. So instead of relying on your teammates or something, you can do it simply in the prototype. And then they will be forced to, like, they don't need to see the implementation of it, how it is implemented or anything like that. They can simply call that function, use it as it is. So that's also can be a benefit, like from my eyes, like which I'm thinking right now.
Isn't that structure? What you gave an example was a structure.
Exactly why I did not want to cover these things, because then the question will come: structure versus behavior versus creation. Why is this creation? Why is this structure? Why?
Then probably it will be better, like if we put this question after learning all three, then we can like differentiate, right? Okay, this is structural, this is creation or something like that.
Hi Keerti, I have one question. In the builder pattern, the file example, you mentioned that all the files need not inherit or implement an interface, right? In that case, what will the director return?
So director will not return anything. You remember while showing the code, I said that it can be just a void, and it can be just builder.build, 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 and it doesn't return anything, right? And then it can just have get product. And what will happen is, so director will have a get product, and inside that it will do builder.get product. And now in my builder interface, there is like just get product that is implemented by every concrete builder, correct? So suppose there is a HP desktop builder. It has a get product. This has a get product. That, like, you understand that every concrete builder has a get product, and then from there will return.
Okay, so then all the products should implement an interface, right? It cannot be like they are independent and not related. They should be one common interface, right? So
no, they don't have to. See, let me repeat. So director, okay, let me just share my screen. I'll have to do it. Give me 1 second. You can ask another question by that time if you want to. Let me just share my screen.
Keerti, for builder, I've seen one example wherein they have removed build also and made the components name as a method name also, so that readability, whosoever client is calling or director is calling, it looks more like I can just put dot and say that okay, dot keyboard, dot mouse, dot and all that. So I don't have to use build.
Instead of build, they are going to say with. So they will say something like this.
Yeah, or they just put like they want to add floor, so they'll put f as small and that will be floor would be the method.
I'll talk about this also in a second. For now, Sri Rajni asked this, correct? So basically, what is going to happen is that so my builder is going to have a get product class, get product method. Okay. Now this get product will do what? It will do builder dot get product, right? And in this, so in this builder, there is one get product, right? So in return type, okay, so you are saying the return type has to be common for us to be able to return. Yes, you are correct. Then if I have to do that, the return type has to be same. Otherwise, we'll have to do from like concrete builder only. We'll have to do that.
Sure, thanks.
Keerti, for builder example on one of the other YouTube channels, Geekyfic, what they had told why we use builder over other pattern was that when there are multiple parameters, like it's a complex object, complex this thing, and if I want to have them as optional, they're optional, then I have to make many constructors, right? Instead of doing that, I put it into this builder format, and whatever I need, I just do that and bring it back. That is what they were trying to communicate in that all of them are void. Then so get product is going to be my main method to get the final product out. But then all these RAM, processor, monitor, keyboard are optional. They're not mandatory in those. And whatever, so if that was their the benefit of using a builder, where my arguments, I would say, or my members are optional.
See, my point over there would be, so you would be forcing to have build RAM, build processor, but they would be nothing. Like you are basically forcing to implement something that is not there. You're violating ISP, right? Like
that's like a bit confusing, because I try to understand other patterns from other sites also, so that I can understand more. But
can
then
you share this video on mail or on separate Discord?
I'll share. Geeky fake. You can just builder pattern geeky fake. I'll share you.
Okay.
Geeky fake site is there.
I have also seen people doing this, but I have read like builder design pattern from Gangs of Four and from other reliable. But you see, it is something that you can do. Like you would want that, I can have like, I can configure it also like that, right? But the point is that according to me, that you would be forcing to have build RAM, build processor, and you are actually violating ISP. Why? Because you have build RAM, but then you're not actually building RAM inside that. That's what you're saying, right? Right? Because it's an optional parameter.
Correct.
So you will have build RAM and then you will do nothing. You will just have like an empty function over there. And
yes.
I think that is never a correct way to go about it, because then we are violating solid principles.
Okay.
Here too, we would like to go with factory on, different attributes for different classes.
Yes, we can have factory.
Keerti, what was the doubt before this?
Sorry?
What doubt was discussed before this? Like I missed that doubt, sorry. It was regarding something that will have to be called in the concrete builder.
Okay, so this get product one that you're talking about?
Yeah, I think that was discussed before that, right? Can you repeat that?
So she was asking that suppose these products, so we talked about the case that when there is no desktop, there is no base class, but there is Dell desktop, HP desktop, Sony desktop, right? So there is no base product. These are different products. So in my builder, I do not have get desktop, but in my, like in this concrete ones, I will have like get Dell desktop product or get HP desktop or get Sony, right? So I'll have to get from here only, because there is no common type of product.
Okay, got it.
So that is what she was saying, which is true. Because if you want to return a common type, then you obviously have to have a common type. You have to do subclass.
Yeah, so one question I had is, like in builder design pattern, if we are implementing new abstract class, then wouldn't we will be violating OCD principle, open close principle?
New abstract class meaning?
New abstract method, if we are trying to add in our abstract class, so wouldn't we would be violating like this open close principle?
So if you talk in terms of that, you would have to make change in builder, this and this, like you would have to make change in all the builders, then you can say you will be validating. But if you think about it, the entire point of interface is that all the builders should have that extra abstract method, right? So basically you use interface or abstract method when you want to set the template, or you want to say that this is the contract, you have to build these things, correct? So in that sense, if you say that if I have another process that needs to be added, OCP will be validated, I would say you are true, you are right. But I would also say that I can add another concrete builder also seamlessly. Correct?
Okay.
So I can say that I am making my code extendable. I am open to extension without modifying the current code. Because
yeah, that can be done.